class 2, you're going to hand out your test. Shira. Jen.
You.
Amanda.
Oh yeah. First
A 14. Again. If you passed, you can leave. But if you failed, I need to talk to you after class. So, Amanda. So, Amanda, first things first. A tangent line is a line that touches a circle on the outside and its perpendicular radius. So it looks like this. That will be your tangent line. So here we will have point A, and here we will have point B, and here is point C, and this is your radius. Now here we have this special thing called the point of tangency, and it makes the right angle to the radius, making it perpendicular. We're going to do a couple of practice problems that are based off the basis of tangent lines. First things first, such as this one. So you're going to draw your circle, and then you're just going to draw a triangle, but the triangle is going to have a tangent line to the circle, just like this. And you're going to have point A, which is your point of tangency. You're going to have this over here where it's x degrees and you need to find it right next to point B. And then point C will be your radius. And we know that the point of tangency makes 90 degrees because, you know, when a tangent line touches a circle, it's perpendicular. Point C is going to be your radius, and that value of degrees will be given to you. So, for example, this will be 58 degrees. So, first things first, you would take 180 because...
Why 180?
I was just getting to that because all the angles in a triangle add up to make 180 degrees. So if you're trying to find the missing measure of one, you're going to subtract the values that are given to you from 180. So you're going to take 180 minus 90, and that is going to leave you with 90 degrees. And then you're going to take the other measure, 58 degrees, and you're going to subtract that from 90. And you're going to get the value of 32 degrees. So that means your x value, your x degree value will be 32 degrees. Where you need to find the x value that is like on the triangle or like the tangent line for this example. So you're going to want to do Pythagorean theorem for this because you have a 90-degree triangle or right triangle. So since we know that this is our radius because the point of tangency here and it's connecting to the radius, so we have 8. And we know that this is our radius because it is coming from the radius into the outside part of the triangle. And we know that this side length is 2, so this whole side, or hypotenuse, will be 10. And this is the x value we're trying to find. So when we set up an equation, we're going to do x squared plus 8 squared equals 10 squared. And that equals x squared plus 64 equals 100. And we're just going to want to subtract 64 from both sides. So x squared equals 36. And to find out what just x equals, we're going to square root both of these. So these cancel. And x equals 6 for a side length of 6. If segments to a circle share a common endpoint outside of the circle, then the two segments are congruent. So after doing the Pythagorean theorem, we had 14 squared plus 18 squared. So the squared of 14 is 196, and the squared of 18 is 324, and that's going to come out to find b is radical 520, and that is all of your measurements for this problem. So now I want you guys to try a problem that is similar to the last one using the same theory about the tangent lines that are meeting, but it's a different setup. But I want you guys to find the x value down here and the whole perimeter once you find this x. The answer of 5 for the x value and the answer of 18 for the perimeter. Let me explain why you didn't. So here we have a triangle and a circle inside of it, and these are all tangent lines to the circle. So if we have 4 over here, this 4 over here is going to be congruent because the tangent lines and the sides are going to be congruent to each other. Over here we have similar with the number 3. So if there's a 3 over here and we have tangent lines, it's going to be 3 over here. Same thing over here. If we have a 2, it's going to be congruent with the 2 over here because of tangent lines. And to find x, we have to add both of these numbers together to get 5. And to find the perimeter, you need to add all the sides up to get the answer of 18. To close off this video, I'm just going to give you guys 2 practice problems I want you to try. So these are the answers to the practice problems. For this one, the simpler one, all we had to do was know that this is a quadrilateral, so we know that all the angles have to add up to 360.
So we did 360 minus 180 because the two right angles, and we got 180. And we subtracted the 33 down here, and we got 147 as our final answer for that x value. So for this problem, we had to do the Pythagorean theorem because we need to find these x values here. So we did x squared because we have two x's plus the 12x down here equals x plus 8 squared, because we need to find this whole hypotenuse, so we needed to add these two values together and square that. So we had x squared plus 144, which is 12 squared, equals x squared plus 16x plus 64. And that will be the outcome of this equation over here, which you would FOIL it. So we would subtract 64 on both sides, and we would get 80 equals 16x, because we canceled the x squareds out because they are on opposite sides. And once you do the division, you would get 80 divided by 16, and your answer will be 5. So the radius equals 5.